gave you the equation of the circle and we put your points into it with the matrix? It was a generalized point. It was x squared plus y squared plus dE plus dx plus ey plus f equals 0. This is the general form for your parabola. Your parabolas look no different than these guys did. However, we can also do a y squared this time. An x squared will open up and down, and a y squared will open sideways. Okay, so do you have to know that format? No. The formats you're going to have to know are the standard formats, these guys. These are what we're going to have to look at. We also throw at you a focus point and a directrix line. A focus point is inside your parabola. Put a point inside. A directrix line is going to be a line outside your parabola, equal distance away from your vertex as your focus is. And we're going to take a look at this. This is a good sheet to keep handy when we're going through these. It's got formulas on here. However, you do not have to memorize these formulas. You don't have to memorize this one. You don't have to memorize it. You just have to find, and we'll find your vertex. We'll use those formulas, but we'll do it on a graph, on our sketch, instead of memorizing when do I add X, when do I add P to H, when do I add P to K. The important part is your vertex. Your vertex is your HK. Center of your circle, remember doing the HK, y minus h squared, x minus h squared plus y minus k squared. It's the center of your circle, it's your vertex, it's your center of your ellipse, your hyperbola. In your parabola, it is your vertex. There's no really other point we need to know. And it works just like an XY point. In alphabetical order, X is always with the H, Y is always with the K, no matter which one comes first. We set this up so that your square is on your left-hand side and your other one is on your right-hand side. This is probably the only one that you have to remember. That P is the distance between your focus and your vertex point. Focus minus vertex. Do you have to remember it in that order? No, we're going to find it. So I don't want you to panic over these equations. I just want you to kind of get used to them. When we look at this, if here's your x squared ones, x squareds open up. When P is positive, it will open up. When P is negative, it will open down. Your P comes from the distance between your vertex to your focus, right here. If it's positive, it's opening up. If it's negative, down. If you're on the opposite side, if it's positive, you go to the right, towards the positive. If it's negative, you go towards the left, towards the negatives. So those are the things we're going to be taking your parabolas and we're going to be moving them around a little bit. Once you put something in vertex form, it's really easy to sketch from because now you have the vertex and we can find the focus, we can find the directrix. You'll probably not need to do anything with a directrix and a focus, at least in this course you won't. But you might get to college and whenever they do parabolas, for some odd reason, they always talk focus and directrix. I really don't know when you would use them that much, but so that we know them and we know they're there, we'll find them. You probably remember when we did your complete the square, we did the quadratic formula, then we did complete the square, and we found your roots that way. This is a nice way to find your roots. It's like we will complete the square with this. But the problem is we'll just move it over to the other side. So let's take a look at one of these. I think once we look at it, it will be a lot easier to understand. Now I want you to keep your sheet handy. So there's a parabola, and the squared part is the y squared. So we're going to go to the y squared part, which is the right-hand side. And I'm just going to write this equation down. This is a parabola that's going to open up to the left or to the right. It's a y squared. So our goal is to get it in that format. We want to get the square part on the left-hand side of the equal side. This is the square part. We're just going to move this whole little thing over to the other side. And if there's no number between this negative and a parentheses, the number is 1. So I'm just going to put the number 1 in there for now. Now, from here, you can find your vertex of your parabola. So your vertex is x, y, h, k. So with the x, this is where the h goes. With the y, this is where the k goes. Okay? And it always comes out in parentheses the opposite way. Remember from your transformations, anything in parentheses went the opposite way. And it does so because of this. If I say negative 2 is equal to negative k, I have to solve for the positive k, k is 2. If I say 3 is equal to negative h, I have to solve for the positive h. So my h is negative 3. So my vertex will be negative 3, 2. This is an important piece that I need to graph my parabola. So right now I know my vertex is at negative 3, 2. I know it's going to open to the left or to the right. What tells me which direction is this right here. This is equal to 4p. Okay? So we solve for p. We divide both sides by 4. And on your thing, if p is negative, we're going to open to the left. So p is negative. We know it's a y squared, so we're opening to the left. I'm not going to worry about the y-intercept or the x-intercept today. Just to get the parabola going where it needs to go. So far we can sketch your parabola in vertex form. We can't do that with your regular one. And a y equals, and a y squared, you've really never been able to sketch at all. So from here, we're going to find your focus and your directrix. Now, you see your chart? We're on the right-hand side of your chart. It gives you an equation for your directrix. It gives you an equation for your focus. But we're going to find it without the formula. Because this is your axis of symmetry line. Your focus sits on your axis of symmetry. It's inside the parabola. And your focus was your vertex, was your the difference between your p difference right in here. Your p is the difference between your focus and your vertex. Doesn't matter which order it goes in, we're going to find it. So p is negative 1/4. We're going to move this vertex. We're just going to find the point negative 1/4 away from it. Is it going to change the x or the y? The x. So watch how easy this is. The focus will therefore be one quarter more to the left, so negative 3 1/4, 2. And if you want to change this to an improper fraction, which probably looks better, negative 13 over 4, 2. Don't use decimals. Now, look what your formula says for focus. Your formula says, on this side, the right side, so we took your h value, and we added your p value. And we got negative 3 1/4, and k was our k2. Did we really need to use that formula? No, we can find it without your formula. We know that the focus is inside the parabola. Now, the directrix is equal distance on the outside, and it makes a line. So let's just find the point equal distance over here. I want to go 1/4 to the right of this vertex point. So what will that point be? Negative 2 3/4, 2. Now, this is going to make a line. It can't be the axis of symmetry line. It's the line perpendicular to your axis of symmetry. Your directrix is this line. So when I make a vertical line, is it x equal or y equal? X equal, and so I want x equal the x value. And I might want to just turn that into an improper fraction. So there is my directrix. Now, according to this, your directrix says x equals, there's your x equals h minus p. H is my -3. P is my -1/4, which forces you to add 1/4. Isn't this your -2 3/4? Did we really need the formula to do that? No. You need to get a good feel just for your focus is inside your parabola, your directrix is aligned outside your parabola. And again, your directrix does not cut through your parabola. So if my parabola is going sideways, I've got a vertical line. If my parabola opens up and down, I have a horizontal line. So can you use these? Yeah, you can. But I would not memorize when do I say h plus p, k, when do I say h comma k plus p. It's very confusing. It's much better to go to this, figure it out where you're going. Basically, those are all the things you need to know about this parabola. You found your focus. We found our focus point. We found our directrix. And I put this, your focus point right here. We found your vertex. We found this. And we found everything. Now, if you were going to graph this on your calculator to check this, you could graph this. If you want to check it, you would take the square root of this. Remember, you're going to get a plus or minus. This is inside under your radical. This is what we did when we completed your square and we solved for your roots, and then we added 2. So if you wanted to put this in your calculator, you could do this. You could pull this up and you could check on this. So we're going to say, I'll do the -1 first. Mine's the old software, so I have to use parentheses. And then you're going to do the positive one. You have to do it in 2 swoops, just like you do the circle one. When we graph this, it'll graph half and half. For some odd reason, it doesn't seem to come together there. But our vertex, we said, was at -3, 2. So I'm going to put in this value for -3, and you see your vertex there? If you looked at your table, symmetry is a little different looking on this. It's a little bit different. Your symmetry is a little tougher to find because you're not going, you got to be careful of where you're going with this guy. It has nothing to the right of it. So your symmetry is a little bit different in here. You really can't spot it. You don't have that symmetry like you do when you're up and down. So it's easier just to put a point and then plug it in. So we took your parabola and we graphed this. You never were able to graph a y-squared one before, right? We never really graphed it. We knew they went sideways, but we never really graphed them. So this is a nice way to be able to graph them. Obviously, this is leading up towards, well, if I got the squares in there, tomorrow I must be completing the squares to get there. We're going to take that general format and we're going to get it into your standard format. All right. Now let's try another one. Here's another parabola. Your goal is to set it up to follow this format. So notice the x squared, the y squared are always on the left-hand side. So I want this on the left-hand side. So I'm just going to turn this around right now. And I need to get it by itself. What's the vertex of this? I have nothing here, so isn't this the same as if I put a 0 in here? Right? So what's my vertex going to be? 0, 0. Because there's no plus or minuses in there. Now, I want to get back to here. I want to divide both sides by 2. Got to get the x squared by itself. And notice my format. My format says x minus h squared equals 4p y minus k. So I found my vertex at 0, 0 because there's nothing plus or minus for this. And now I got to find where this is going. So I say 4p is 1/2. I got to solve for p. So I'm going to divide both sides by 4. And when you divide a fraction, it's going to get a lot smaller because you're going to divide 1/2 into 4 equal little fractions. So it's keep, change, flip. So my p is equal to positive 1/8. This is important for me. It's a positive and it's a little tiny number there. So that means I have an x squared and a positive p. Which way is my parabola opening up? Up or down? Up. Kind of said the up. So here I am at the 0, 0. I'm opening up. We even know a dilation in here. We know what your dilation does. We know from your transformation it makes it a little narrower. It stretches it out. Okay, so now we're here at your 0, 0. Let's see if we can find your focus and your directrix without your formulas. Your focus has to be inside your parabola. And your p is 1/8. And if I move up and down, am I changing my x or my y? Your y. So give me the coordinates of your focus. You're changing your y, so 0, 1/8. How easy was that? Your focus formula said h, k plus p. The h is going to stay the same, and your k was 0 plus 1/8. Wasn't it much easier just to find it rather than use the formula? I knew as soon as we did an x squared, you'd see it a lot easier. Now, your directrix is equal distance down here. Find the point first. So if I drop to this point goes down. So this point is at the 0, negative 1/8. I'm going to make a line because I can't cut through my parabola. And a horizontal line is a y equal line. So tell me what the y value is of that point. Negative 1/8. There's your directrix line. This is your directrix. Yeah, now your directrix formula says y equals k minus p. K is 0, minus 1/8, and there it is, negative 1/8. So can we find it without using all those weird-looking formulas? Yeah, we can absolutely. We can sketch it, and we can find it. Okay. So we found your vertex, we found your directrix, and we found your focus point. Your focus point is inside your parabola. Your directrix is a line outside your parabola, and it can't cut through. So if your axis of symmetry is a vertical line, your directrix is perpendicular. It's a horizontal line. If it's sideways and your axis of symmetry is horizontal, your directrix will be a vertical line. Make sense? Okay. So I want you to do the homework. Get familiar with